it becomes x to the n on the bottom. So this becomes 1 over 10 to the power of 3. So that 3 goes down to the bottom, becomes positive, and then that's 1 over 10 times 10 times 10, which is 1,000. Any questions on that?
No?
Okay, so let's get to the ones you were asking about here. 13. We have to review a couple of properties. So when the bases are the same and you're multiplying, you add the exponents. So that's in words here. It's often written like this, like x to the n times x to the m. See how the bases are the same. You add the exponents. So in 13, you have y(x) to the 1/3 times xy to the 3/2. So what I would have you do potentially is rewrite the order of this, pair up the x's, pair up the y's. Now notice I'm writing y to the 1 and y to the 3/2. So since the bases are the same, you're going to add the exponents. You're going to add 1/3 plus 1. And then
Right.
similarly with y, you're going to add 1 plus 3/2. And hopefully you're getting faster at adding fractions. But if you're not, they're not going to be big numbers, but you're going to have to deal with fractions. So it's 1/3 plus 3/3 times y to the 2/2 plus 3/2. So that's 4/3 and then 5/2. Any questions on that?
No, not so far.
Not so far. So like what I don't want to do is just jump into like another problem here. I want us to do a couple like this because this is a core property that you have to be able to do. Like you have to be able to do this without any issues. So let's try another one here that I'll make up. So this is just an example. Let's say it's u squared v to the 1/2 times u v, let's go 1/5 and like that. Okay, let's try this one here. This is very similar to the one that your instructor just gave you. So you pair up these u's, and it's really u to the 2 plus 1/5
Right.
times, not plus, times, because everything's been multiplied here in the equation. 1/2 plus, what's the exponent above v?
1.
1. Now on the right here, whenever it's plus 1, you just go 2/2 or whatever the other denominator is. You grab the other denominator and make it that number over itself. On the left though, 2, not quite as friendly. You may have to come over to the right and say, okay, it's 2/1 plus 1/5. Your common denominator is 5. So that means you multiplied the top and bottom by 5. So you get 10/5 plus 1/5. But you, as the math student, have to be able to be comfortable adding these fractions. Any questions for me on this example before I have you try one here?
No.
Okay. All right. So it's let's do a b to the 1/3, a to the 1/5 times b. Can you try this one on your own, please?
I got A to the 8/15 times B to the 4/3.
Okay, so I like the B to the 4/3. It's A to the one, it's A to the one here.
Oh.
Go ahead and give that another try, please.
Okay. 6/5.
Yes. Okay, good. So let's look at 14 together now on your worksheet. 4v to the 2/3 times v to the -1. The thing that I want you to take note of here is that the four is just going to come with the answer. But if there, like, let's say there was a 3 here, you would multiply those two numbers.
Right.
Okay, but there's not, so we don't have to worry about that. Now you're just adding the exponents. Okay, now sometimes you're adding a negative number, right? That's okay. It just becomes 2/3 minus 3/3. So it becomes 4v to the -1/3. But what does the instructions say right above it? I don't know if you can see that, if you've got the sheet out or not.
Simplify.
Yeah, what else? What about to the right of it?
Um.
It's okay if you don't have it. I just couldn't snip it in just fast. My snipping tool wasn't there.
Oh. Your string will only contain an exponent.
Yeah, positive exponents.
Yeah.
Positive exponents. So like it's like I thought I had it figured out, you know, I got these right. So we kind of saw this in an earlier problem, but the property is that if you have a negative exponent, you write it as 1 over x to the n, and this x is really whatever is contained in parentheses here. So for this problem, it becomes 4 over v to the 1/3. Now, like, this is just a preference. It is like what they want. You have to give them what they want, but know that this is just a math thing. It's like, this is correct. The previous line is just that the next one is preferred. And that's what you have to give for your final answer. So let's look at another example here. Let's say it's 5x to the -2 times 3x to the 5/6. To simplify this, we would multiply the 5 and the 3 together, 15. And then you do add the exponents. It's -2 plus 5/6. So that -2 is really over 1. And you do want to make a common denominator. What would the common denominator be here, Paige?
It would be 6.
6. So you have to multiply, and sometimes you got to come off to the right to figure it out. You have to multiply the top and bottom by 6. So it's -12 over 6. And then you're adding that 5 over 6 to it. And so, okay, that's -7 over 6. So 15x to the -7 over 6, but it cannot be a negative exponent. So you have to move it to the bottom. Is that okay? Is that
Yeah.
all right? So I'm gonna have you try one here. Try this. Let's go 3a to the -1, a to the 2/7. Yeah, I'll have you try that. How are you doing on this one?
I got 3 over a to the 9/7.
Okay, so A though, or I'm sorry, the exponent is -1, so that would be -7/7.
Yeah, that's what I put.
Okay, but when you add the tops here, it becomes -5/7.
Oh,
I heard something else.
oh, never mind. I made a stupid mistake. I accidentally subtracted, not added.
Yeah, we're gonna get to subtraction here in a bit.
So it'd be -5/7.
Yeah, but this would be, you know, let's say it's a 10-point question, it might be like 8 out of 10 points for that. So you have to write it with A on the bottom, 5/7.
Right.
Okay, so let's talk about another property that is given on this worksheet. It's anything to the 0 power is 1. Anything to the 0 power is 1. So you see that in question 16, and you got that right. Now what some instructors do is they give you something really complicated and they like distract you. They just distract you from looking at the exponent, but it's 1. Okay, so let's integrate that into some of the problems we've been working on. What is x to the 0, y to the -1, x to the -1, y to the 0? So when the bases are the same,
Mm-hmm.
what do you do to the exponents?
You combine them,
Okay, what math operation do you use to combine them?
usually adding.
You because we're multiplying, you add here.
Yeah.
So this becomes, excuse me, go away, come on. Okay, there it is. 0 minus 1, or 0 plus -1. And then what about this one here? Same thing, -1 plus 0.
Yeah.
So what is 0 minus 1?
-1.
-1 times y to the -1. Is this okay the way we've left our answer?
No.
No, we have to write it as 1 over x to the 1 times y, sorry, 1 over y to the 1. And you could just combine it into something like this.
Right.
Okay, now I'm going to go back to the original question because it's like, well, hey, what about this property up here? You just said anything to the 0 power is 1. Well, you can choose the order to apply the rules. So order of operations does not apply here, meaning that like it's not like there's a priority. So you could say, all right, well, x to the 0 is 1. And y to the 0 is 1. 1 times 1 is 1. You've got 1 over y times 1 over x. So it becomes 1 over x times y. So you end up getting the same result. You as the math student here, sorry about that. You as the math student have to decide, you know, which order do you want to apply them in? What makes sense to you? Is that okay? Clear?
Yeah.
All right, let's try one more here. Let's say it's a to the 1/2, b to the 0, a to the -1, b to the 3/4. Could you simplify this one for us, please?
Is it 1 over a to the 1/2 and b to the 3/4?
So the final answer could look like this. Is that what you wrote?
Yeah.
Yes. I know I gave you maybe a little bit variation on what we're doing, but yeah, good job on that. Okay, great. So we're just increasing like the difficulty, we're increasing the number of rules to have to remember. So the next rule is that when the bases are the same, but this time now you're going to divide, or you can think fraction bar. This time you subtract the exponents. So like formally it looks like this. If you have x to the n over x to the m, this becomes x to the n minus m. You subtract the exponents. I'm assuming you saw that in class.
Yeah.
All right. So for example, if it was like y to the 7th over y to the 5th, it would be y to the 7 minus 5. But what if it was something like this, like y over y to the -2? What is the exponent in the numerator? What's the exponent not written here?
Oh, 1.
1. Yeah. So this becomes 1 minus a -2. And what I really recommend is that you look at this fraction bar like a big minus sign. Big minus. To help remind you that that goes there. So this becomes y to the power of 3. Any questions on that?
No?
Okay. So so here's one for you to try. Let's say it's x to the -2 over x to the -8. You have an answer for me on this one?
So I got to x, exponent negative, like x1 over x exponent -10.
But okay, so this
Oh,
this is why this is so critical. We're not, and I know the problems get way more complicated in your assignment. We got to build up from like it's subtracting whatever it is. Like even though it's already negative down here, this really is x to the -2 plus 8.
so it would be 6.
Yes. Okay, let's try another one here. So if you have more than one letter, so it'd be like, let's say we had a to the 0 over a to the -5, b to the 1/2, b to the 1/3. Okay, so we'll do this together here. It's really two separate problems in one. It's really okay. It's 0 minus a -5. And if you do that, I think it's less awkward. You're unlikely to forget, I guess would be the thing. For B, it's 1/2 minus 1/3. So this first one, even kind of where you have to find a common denominator here. So it's 6. So you multiply the 1/2 top and bottom by 3. That gives you 3 over 6. The 1/3 top and bottom by 2. And that becomes 1/6. So this is B to the 1/6 power. Now let's say you were like, well, hey, I really want to treat a to the 0 as 1, which is totally fine. it still works out the same. You just have to remember how to deal with this. It is a property. It's related to the one that we looked at earlier. So a negative exponent basically flips from the bottom to the top, or goes from the top to the bottom. So in this top rectangle, the negative exponent goes to the bottom. In this bottom rectangle, the negative exponent goes to the top. Is all this okay right now?
Yeah.
Okay. Because we're about to really, like, you know, increase the difficulty, because that's kind of what happens to these problems, is they all sort of, you feel good about them individually, and then it's like, oh no, I got to do these horrible things. There is one more rule that we need to look at, but I'm going to do 18 first, and then we'll have all the rules down, I think. See here. So 18 is a good problem for us to look at together. Okay, so this is really good. It's like, okay, the twos cancel, great. But I've got X on the top, X on the bottom. So when the bases are the same and you're dividing, you subtract the exponent. So I always recommend just writing out what it is rather than trying to do it. And then the same thing with the Y's. You're dividing, bases are the same, so you subtract the exponents. 1/3 minus a -7/4, like that. Is that okay? Clear?
Yeah.
All right, so on the 3 and the 2, your common denominator is 6. Do you like to work the fractions off to the side, or do you like to work them in with the X? Like, is it easier for you to work this in line with the problem, or do you come off to the side and work it out?
I usually go off to the side.
Okay, let's do that. So let's go 1/2 minus 4/3, 6 and 6. So it's 3/6, 8/6. It's -5/6. So again, don't try to, like, oh, I've got to move it to the bottom. Just do one thing at a time, baby steps. Walk, you crawl before you walk, then you stand up, then you walk. The 1/3 plus 7/4. So that's a common denominator of 12. So it ends up being at 25/12. And this is the point where you would actually be like, okay, I'm gonna manipulate them. So the X to the -5/6 goes to the bottom. There you go. Any questions on this one?
No.
Okay, because I want to give you one like it to try. So just look it over. It'll be really similar, just different numbers. Any questions? Got it. Okay. 6x to the -1/2, y to the 1/3 over 3x to the -3/4, y to the 2/3. I'm just gonna step away for 30 seconds, but I'll be right back.
Okay.
How are you doing on this one, Paige?
So I got y to the first over 2x to the 1/2.
Say that one more time. I'm sorry. 2x to the,
1/2.
okay, and then,
Y to the first.
okay, so remember the key here is that when you're dividing, you're subtracting the exponent. So it's -1/2 minus a -3/4. Y to the 1/3 minus 2/3. I think that'll change. I hope that changes your answers here a little bit. So the first one here becomes, we'll go do it off the side here, -1/2 plus 3/4. So your common denominator is 4. And so that becomes 1/4. The 1/3 minus 2/3 has already got a common denominator, so it'd be -1/3, like that. And then the 6 divided by 3 is 2. Right, and then so what do we do with this negative exponent here? What's the change?
You flip it.
Yeah, you move it to the bottom here. So 2x to the 1/4 over y to the 1/3, like that. Okay, let's have you try one more here. Just really try to follow, you know, subtracting negatives, subtracting, keeping whatever it is. Next one here. So let's go 9 over -3, x to the 5/6 over x, y to the 1/2, y to the -1/4. Go ahead and try this, please. Let me know if you have any questions.
I got x to the 4/5 and y to the 1/3.
Okay. So when you divide here, you're going to subtract the exponents. So 5/6 minus 1, usually a 1 there. Y to the 1/2 minus a -1/4.
Mm-hmm.
So the on the x here, it's the common denominator. We'll call it off the side here, 6 over 6. Okay, so that would be -1/6 for that, x to the -1/6. And then with the y, you're going to have to make a common denominator. You're going to, let's go over 4 over 4. So that's 2/4 and 1/4. So that's 3/4. So I can't see your paper or what you're working on, but I can only presume that the issue is with the adding and subtracting of the fractions.
Hmm.
And I know this isn't super exciting. It's kind of drudgery. The problems get a little harder for me. I'm avoiding trying to make them more difficult, but because I want you to obviously get this down. So let's try one that's slightly easier here. Let's go to 17. And you're not alone here with these fractions. Like everybody's struggling. Everyone's like, oh, can we just get all right, so go ahead and try this one, please. I'll step away for 30 seconds and be right back. How are you doing on this one?
I got a to -2.
Okay.
Yeah.
And then the 3 stays on the bottom.
Yeah.
So this becomes, the question is, well, what do you do from here? And remember, you can really kind of put a 1 up here up top. So this is 1/3 times 1 over a squared. So this becomes 1 over 3a squared like that. Okay, let's try a couple more of these that aren't so awful. Let's just get a couple of ones here. So let's go a to the 5th, a to the -8, b to the 0, and let's go 4 up top, -8 on the bottom. All right, so when you look at a problem like this, you really want to break it up into 3 separate problems here, like this: 4 over -8, a to the 5th over -8, and then put a 1 up here, 1 over b to the 0. So you just work them individually. So what is 4 divided by -8?
-2.
-1/2.
Oh,
Negative one, because
yeah.
yeah, because the number in the bottom's larger, so it's got to be a fraction. Now again, like you could probably do it, but I would recommend just writing it 5 minus a -8. Don't try to make too much out of it. We're just working on these little pieces, and then b to the 0 is really 1, so it's really, oops, sorry, just screen just isn't responding. There it is. So the last part here becomes 1 over 1, which we don't even need. All right, so it becomes -1/2 a to the +13, and you're done because you have all positive exponents. Okay, so let me give you one to try here, just a little more difficult, but I'll keep the exponents integers. So let's go -20 up top, a to the 0, b to the 5th, c to the -9, -4, a to the 5th, b to the -5, and c to the 5th. But you really want to treat this like it's 3 separate problems. 3 separate problems here. Let's give that a try, please.
I got 5 for the first one, and then -5, 10, -14.
So a to the -5, b to the 10 you said, and then c to the -14.
Yeah.
Good. Okay, now could you now write it with only positive exponents? How would you rewrite this with only positive exponents?
You would put the ones with negative exponents on the bottom.
Yeah, so 5 b to the 10th, a to the 5th, c to the 14th.
Yeah.
Okay, so let's talk about the last property here. The last property is that if you have a x to the n and you raise it to an exponent, so you raise it to a power. Okay, this time you multiply the exponents.
Okay.
So in terms of like what this becomes, and this equals x to the n times m. So here's an example. Let's say it's x squared to the power of 3. This becomes x to the 2 times 3 power, or x to the 6th. Let's say it's x to the 1/2 to the 1/3 power. This becomes x to the 1/2 times 1/3. And I think this is where, as a student, you have to sort of pause and say, okay, like I was adding, but now I'm multiplying. What's the difference? Oh, I multiply the tops and multiply the bottoms. And so there's a lot of rules, a lot of mixtures, and you have to be able to work between those.
Right.
Okay. And of course, you could get some negatives. It could be like x to the -2 to the -1/2. This is x to the -2 times -1/2. And then you multiply the tops 2 over 2, and then you simplify and get something like that. So an extension to this type of problem is that let's say you have x to the n times y to the n to the m. You end up multiplying each of the exponents. So this is x to the n times m, y to the n times m. So the example I'll give you here is what if I give you x to the 4th, y to the 6th to the power of 2. You multiply the exponents. It's 2 times 4, 2 times 6, x to the 8th, y to the 12th. But of course, your problems are going to be more difficult than this, but this is generally the idea here. So let's look at we'll look at a few problems here together. I won't ask you to do anything on your own, but we're now really kind of coming up with the problems you would see on a test or a quiz. So 22, there's a lot going on here, but we're going to focus our attention on this right-hand part first. So here you have an exponent to an exponent. And this is when you multiply the exponents. So it's u to the 3/2 times -3/2, which is u to the -9/2. Is that okay?
Yeah.
Great. So it's u to the -5/4 v squared times u to the -9/2. So now the property we're going to use next is that the bases are the same. So what do you do when the bases are the same and you're multiplying?
You add them.
You add them, yeah. So it becomes u to the -5/4 plus -9/2. So you got to make and then we'll bring the v squared down. So you got to come off to the side here. What's -5/4 plus -9/2? Make a common denominator. And it looks like it's -23/4. So it's u to the minus 23 over 4 times v squared. And then the negative exponent has to go to the bottom. Something like this.
Okay.
19's a bit easier because it's kind of all positive and nice, but you can see from there on out, it kind of gets pretty awful. So we got u to the power 1, v to the power 1, u to the power 1, and then you've got this v to the 3/2 to the power of 3. That's the exponent to the exponent. And you generally apply the exponent rule first, but not always. So, but this is v to the 3/2 times 3, which is 3 over 1. And so when you multiply the tops, multiply the bottoms, and then you just bring everything else down. U to the 1, v to the 1 times u to the 1. The ones that have the same base, you add the exponents. And then you do the same thing for the v's, v to the 1 plus 9/2. So you get u squared, 1 plus 9/2. 1 is really 2 over 2. So that's 11 over 2. V to the 11 over 2 power. So this is one of those lessons where, I really would recommend redoing the problems we did because there's so many little intricacies to them. You'll get a lot of value out of it. I would be cautious about going past like question 22 at this point.
Yeah.
Just to be very careful. This is also the one that we they're like misnumbered at some point. 18, 19. Anyway, that's a weird 13, 14, 15, 16, 17. They're just not lined up right. Okay, never mind. This just looked awkward. That is it for us though for tonight, Paige. You mentioned wanting to meet in person. Let me just stop the screen recording here.
Okay.